Good morning, welcome, and thank you for joining us. My name is Dwayne Henderson, a member of Cree Lighting's training and education team and host of our e-learning series. For those watching live, happy Wednesday. Quickly about the session, once we get going, we'll have about 15 minutes of content. The presenter will remain on the line for Q&A. Although the attendees are muted, we do encourage you all to use the chat and Q&A box to ask questions. Feel free to type those in during the presentation, and again, we'll loop back and answer those at the end of the session. Wednesday is industry-related content day, and today we'll gain a better understanding of bug ratings. And to walk us through that, I'd like to welcome back John Vollers. Good morning, John.
Good morning, Dwayne.
John, before we get started, can you quickly remind the audience about your role in the business?
Sure. Hi, my name is Jonathan Vollers. I'm the technical manager here at Cree Lighting, mainly focused on lighting qualification, which includes Energy Star and DLC listings, as well as managing our accredited photometry lab.
Perfect. All right, let's get started.
All right, so today we're going to talk about bug ratings. So entomology. Wait a minute, not these bug ratings. We want to look at these bug ratings. Okay, so backlight, uplight, and glare, the BUG of bug ratings. So those ratings stem from TM15, which is an Illuminating Engineering Society, or IES, Technical Memorandum, TM, on a luminaire classification system for outdoor luminaires. Makes sense. Down here, we can see the graphic here where we understand what the BUG means. So mainly focused here, backlight, uplight above the luminaire, and then glare, looking here mainly at the forward light, forward throw of the luminaire. An example of that, or a tested example of that, is this OSQ luminaire here. Happens to be like a type 3 optic, so a lot of forward throw of light. So you can see the light being generated in the forward zone, and then the back light zone here were identified in purple. And then you can see there is no uplight. So our rating on this particular product happens to be a B3, U0, and G3. So as we get a little bit deeper into the presentation, you'll start to understand, well, what does B3 mean? What does G3 mean? And what does U0 mean? Now, sometimes to move forward or understand where we're at, we need to understand where we were. So the luminaire classification system, it replaced the cutoff classification system from RP8. So this is a little bit of an understanding of where we were before TM15 and the new classification system, or the bug ratings that came out. So the way that the cutoff classification system worked, it had full cutoff, cutoff, semi-cutoff, and non-cutoff. Now those four categories, don't tell you a whole lot. You get a little bit of an idea of how the light is being distributed from the luminaire, but you don't really know how much light, in what zone it might be going. It just gives you a general indication of its light and the way it's being applied. But to understand them a little bit more, you can see down here in this where the actual values come from and what could be called a full cutoff, cutoff, or semi-cutoff. Full cutoff here has no uplight. So that was, an addition that was later. This system's actually been around since I think the 60s. But full cutoff was added later when they wanted to start stopping upward light and really start looking at dark skies. So this full cutoff has no uplight, but it has that, up to 11% within 80 to 90 degrees, or at what's considered a high angle. And then if you look here, cutoff has upwards of 16% going upwards. If you're talking a 10,000 lumen product, that's a fair amount of light going up, and it's still called a cutoff. So that's a little bit confusing. And then obviously semi-cutoff is having upward light. You can see here in this graphic, it's actually trying to distribute light to some extent upwards, maybe to showcase a wall, who knows what, for what particular application, but upwards of 31% is allowed going up. That's quite significant. And then obviously non-cutoff isn't even mentioned here because it has no control. It is allowed, might be a globe, maybe more of a decorative item in a street, like a downtown street light, which is showcasing the facades of the buildings as well as maybe some trees. So that has no limits on how much light can go up. So again, this has a little bit of understanding of the luminaire, and some visual representation here is helpful, but it doesn't tell us a lot about what the light's doing also below the luminaire, and maybe understanding how to compare one full cutoff luminaire to another full cutoff luminaire. So that's where the TM15 and the luminaire classification system came into play, and the bug ratings came into play, is to help define them a little bit better and then allow us to compare one product to another for any given application. So let's get into what the bug ratings mean. Backlight, so the B, is trying to understand the impact of lighting directly behind the luminaire. And you can see in this plane view from 90 degrees to 270, so behind the luminaire, where it's going to be installed in the application. You can think of, and it's also broken up into these 4 zones in the vertical direction. So low, mid, high, and very high. And you can think of the low and mid zones kind of what your impact is on the curb and the sidewalks, and maybe even into a yard if it's a residential area. So that's an area where you actually might want light coming out because you want safety and security. You want that sidewalk illuminated. So that helps you understand, depending on your application, you may want a certain amount of backlight. And then in other applications, you want to limit the amount of backlight. And the picture down below might be one of them. But also to understand the high and very high zones, that's typically light that isn't very useful. It's possibly going to be a glary, and this actually is part of the glare metric, the G, later as we get into that. But you can see here in this application, this luminaire is sending light down and actually is even hitting the 3rd story of this building. And so you can see that the light is really not being controlled. There's a lot of backlight, really not great. And I'm sure this homeowner is not really happy with this fixture. Possibly a selection of a unit with a lower B rating would have been better, or possibly even adding a backlight shield, which helps even further really limit and possibly get this light distribution below that 2nd story. Obviously, this might impact, as we've talked about, circadian health. This is impacting if anyone's trying to sleep in those rooms. So unfortunately, this didn't have a lot of, maybe they weren't looking at the bug rating when they were installing this unit or selecting it. So now we're going to talk about U. U is the uplight. And that's really obviously understanding the impact of lighting above the luminaire. And you can see that here, and it's broken up into 2 zones. The low zone is between 90 and 100 degrees, and then high is everything above that. Most applications around the country, certainly roadway applications, require a U of 0, so literally 0 uplight going into these zones. But it helps understand that a U of 1 is actually very limited as well. It's only upwards of 10 lumens in the low zone and 10 lumens allowed in the high zone. So you're looking at maybe upwards of 20 lumens. So a U of 1 isn't necessarily a limiting factor for applying a luminaire to your application, as long as that U of 0 is not required. So because you're really talking maybe upwards of 10, 15 lumens compared to the 10,000 lumens or more that is being thrown down on the ground. So the application might be absolutely acceptable for it. And it's also important to understand that a lot of this U0 came from the desire to recapture our night skies, showcasing down here where we're getting a lot of light pollution, sky glow, and a drive by the International Dark Sky, which is great. But also, when you are in an application, a U of 0 does not necessarily guarantee no sky glow or no light pollution. So you need to understand how much light is being thrown down on the surface, which you're illuminating, whether it's a parking lot parking garage or a roadway, and how much light will be reflected back up. And then also, depending on your luminaire, if it has too much high angle light, you might hit particles in the air or humidity, and that will reflect up and create sky glow as well. So this is just one piece of information. The B, U, and G are just pieces of information that help you make better selections in your applications, but it's not the only piece of information. It needs to be taken as a whole. So here we're going to look at the G or glare rating, and really this is more possible glare zones. And glare, it's really a simplified term, and the value G doesn't necessarily mean that the luminaire is glary. You know, just because there's a number there, it's actually putting light maybe where you want it, depending on the application. And one of the things I'd say about that is that bug sounds better than boo-ha. So, you know, backlight, uplight, and high angle light. So bug is probably what kind of got selected there, as it's much more catchy. But again, so the glare metric or rating focuses on the high and very high zones, both in the forward light here. So you can see the high and very high, so 60 to 80 and then 80 to 90 degrees on the forward side, but also on the back side. So, you know, you need to understand that it does actually rate both for forward and backlight. And you can see here in this application, probably one of the biggest concerns is in a roadway application, where if you're getting too much intensity in this high, very high zone, as you're driving upon this roadway light, this luminaire, depending on its pole height and depending on its intensity, it could cause a driver to have really almost some disability glare where they're not able to see well. And that is certainly a safety issue where you can have, you know, they're not identifying a pedestrian, maybe miss a stop sign, all these things that can affect their ability to drive and create an unsafe environment. So that's certainly a very, very important aspect of this selection for this luminaire and understanding how much intensity is in those high and very high zones. The other thing I'd say here is if I was this homeowner, I'd be really unhappy with this selection, as I'm really getting bathed in light, and you know, certainly the second story is bathed, and you're really probably going to be a little difficult to sleep if you don't shade those rooms very well. So here we're going to look at the actual where those ratings come from. You know, again, this is absolute lumens. These tables are in absolute. And compared to the previous system, which was percentages, so as you went higher, you could actually have more light in these zones, and it wouldn't change your you know, whether you're cut off or semi-cut off per se. Here, these are absolute lumens. So if you're a 5,000 lumen Cobra head or a 40,000 lumen area light, your rating is going to change based on the amount of lumens that you're putting out in these zones. Here we're showing the backlight rating. This really looks at the low, mid, and high areas. And then you can see the cutoff points. These are 1,000 lumens, 2,500 lumens for the different ratings. Then here in the uplight rating, or the U, you can see the two zones that were identified before and the lumen values that would correspond to that rating. As I mentioned before, you know, a U of 1 is actually not a lot of lumens. U of 2 is only 50, so still not a ton more. And then over here in the G metric, you can see that there's actually two tables, and that's important to understand because different types of luminaires have different distributions of light on purpose. They're used for different applications. So that OSQ that we're going to look at, or that we looked at earlier in the slide deck, was a type 3. So that's an asymmetric luminaire where it's throwing light very in the forward zone, and is going to have less light in the backward zone. So this would be rated based on this table. A product that's a type 5 or type 5 square is really more of an area or parking lot light, where you're really wanting distribution all the way around the luminaire. So your zones are actually going to be even both forward and backward. So these are important to understand when you're applying these metrics. So let's look at the example that I showed earlier. I'm going to add here, again, this was a B3, U0, G3, and you can see the breakdown of lumens in each zone. So I applied a square around each zone and its value. So for this particular OSQ, the backlight rating was a B3. And you can see here that in each zone, it was less than 2,500 lumens. And note, the expectation for backlight is that the mid zone is going to have the most lumens. So therefore, a B2 is actually 2,500 or less. A B3 allows for up to 5,000 or less. But whatever zone you're in, the highest zone you're in any of the vertical zones is going to dictate that you're a B3. You don't get any, you don't get 2.5 because you have one of the zones here. The uplight rating, easily, there's no uplight on this product, so therefore it's a U of 0. And now we apply, as I mentioned, it was a type 3 optic, and so you're looking at this table up here due to its asymmetrical distribution nature. And the very high zone and the high zone, both front and back, the very high zone for front and back, less than 225 lumens, less than 100 lumens. So it's not distributing light at that very high angle, which is great. But we do have, where it does a lot of its work, the forward light is less than 7,500 and the backlight is less than 2,500. So you can see the disparity here between the two for this asymmetric expected distribution. And it's going to be a G3. And if it was a type 5 light, you would see that it actually would allow for upwards of 7,500 lumens in both directions and still be a G3. So this is, hopefully you've seen how the bug ratings are applied, where they came from, and seeing what the values mean here for absolute lumens. Hopefully it was helpful. Thank you.
Thanks, John. Just to remind the audience, if there are any questions, please go ahead and submit those through either the chat box or the Q&A box. John, while we're giving the audience a chance to kind of think of some questions, the full cutoff classification, I still hear sometimes customers talk about that. Just to be clear, that has kind of gone away, and today, if we're considering any of these metrics, backlight, uplight, or glare, we should be transitioning to bug ratings, correct?
That is correct. And I think the full cutoff, when somebody at least mentions that, you'd be, you kind of reverberate back to them or reiterate to them that it'd be a U of 0 is what you're looking for, would be equivalent. And then your B and your G are now new metrics that add data. So really that bug rating is going to be a much more helpful tool.
Yeah, one of the other things I found interesting is on the tables, we have the OSQ that you show, but we also have a high output version in OSQ-HO. According to the tables, though, they're really not treated any differently in terms of the amount of lumens that they can have in any of those buckets, correct?
That is correct. And it's important to understand, like if you were applying a 20, 30-foot pole parking light lot, and you're looking at an OSQ maybe in that scenario, that B3, U0, G3 might make sense. But if you're in a high mast application where, you have a 40 or 50,000 lumen product, it's probably going to be a B5, U0, G5. But really you need to make sure that you're comparing units that go into, or products that go into that application. You shouldn't compare a product that's designed for that high mast application and a product, for a roadway or a, maybe a residential area. You're really kind of comparing apples and oranges because of that absolute lumen value.
Yeah, so if you think about like the 60-degree main beam, or where the highest intensity of light is coming from a luminaire, and if you exceed that, there's some benefit sometimes of doing that. So I always talk to customers about the reason we might want to do that is if my pole spaces are greater apart, I can kind of fill in the gaps between the poles, and my economics can be better. So there's certainly trade-offs in terms of trying to manage all of this, and if you get too restrictive, you could economically kind of affect the project as well, correct?
Yeah, and I think the thing to understand is that, again, that the bug rating is a piece of data. and that really hitting your illuminance and uniformity ratios. So those are really your first selective tools where you now understand, okay, I have manufacturer A, B, and C, and they all meet the uniformity I want, the illuminance levels I need to meet the particular RP, the application I'm using. And then I want to go look at the bug ratings for each of those luminaires and say, okay, this has a lower glare rating. Let me look at that. Let me understand that a little bit better. And or maybe I happen to have a light trespass issue with a boundary line, and I want to understand how that luminaire is going to work in that application. And maybe I have more options from this customer A. Hopefully that customer A is Cree Lighting, but it's really a piece of data that's part of the selection process and not necessarily your first piece of data.
Yeah, I know when our design team looks at projects, and we certainly value the lighting design process. A lot of the solutions, we have a type 5 medium and a type 5 short, and the team will often use the short first. And if I can meet the design criteria using the 5 short optic, let's not increase the main beam. Let's manage it that way. But again, if the spacing doesn't allow us to do that, sometimes you have to approach it differently. I guess the last thing I'll mention, John, is sometimes uplight is good. So think about a parking garage, right? If I had a U of 0 on every spec that I wrote, and I wanted a parking garage or for a lot of customers, they like an uplight effect. The ceiling's kind of containing it anyway. We can't form habits around all products and all applications, right?
Absolutely, yeah, and a parking garage is a great. You don't want that cave effect, right, where the ceiling is dark. So having upwards of 5%, maybe typically is what I've seen on parking garage fixtures, which could be, if you're talking a 4 or 5,000 lumen product, it's a fair amount of light. Certainly is going to give you a U of 2, maybe a U of 3, depending on how much light you're trying to produce. So a U isn't necessarily bad, a B isn't necessarily bad, a G isn't necessarily bad. It's really important to understand that what's appropriate for your application.
Okay. I do have a few questions here that popped in. So one question is asking, what's the ideal bug rating? So we talked a little bit about this, but assuming for like a typical, maybe a parking lot or streetlight application, they're asking about a 303. Do you have any comments in terms of what typically would be considered a good or ideal type of bug rating?
Yeah, there's really not an ideal. I think if you were to look at a residential, lower lumen Cobra head, like kind of like our XSP Rs or smalls now, I should say. You might be at a B2 U0 G2, something like that. And then as we showed here, this was a parking, an area light, probably a little bit higher value, maybe 10 to 15,000 lumens, and you're looking at like a B3 U0 G3. So it does give you an indication of, kind of the luminaires getting higher and higher probably in general. But, so there's really not an idea or typical until you get into your application and you understand that you're meeting your application needs for illuminance, uniformity, and then that bug rating helps maybe define between customer A, customer B, or maybe luminaire A, luminaire B, and not so much before you just even select what luminaire A is and luminaire B is.
Yeah, there's a similar question here about, the O2 we showed had a B3 and a G3, and we talked about, that's acceptable. They're asking how do we evaluate acceptable ratings when specifying fixtures. Can you discuss the selective criteria when there is no spec? So how you might approach it when there's not a specification driving it, but you want to try to be aware of these.
Yeah, so it's kind of reiterating some of what I said, but in the more like if I were to go and select a luminaire, so any of those pictures I showed, I would look at, I have a pole, I'm probably doing a retrofit. Not most of our installs are retrofitting, so we're not moving poles, we're not moving pole heights typically. So we have to really take into account, all right, we have a 20-foot pole or whatever is installed in that area. So once I do that, once I understand that, I would go and start gauging my lumens, my lumen values and what I want to replace it with to make sure I get my illuminance and my uniformity that I want to try and be successful on. If I could get that from an XSP and an OSQ and maybe the RSW, I might be looking at these different types of luminaires. I would then go look at the bug ratings and take those into account, saying, okay, I have a home over here. I really want to get my G down. I want all of these meet my uniformity and my illuminance ratios. I want to down select to a better unit that's going to maybe provide better control and not harm this whole house that's sitting over here or create light trespass. So I would really think of the bug ratings as probably more of a down select where you're going from 2 or 3 or 4 luminaires that meet your application, but you want to refine it down to that last one. And that bug rating would be kind of more of that secondary piece of data that would help down select to the right luminaire.
Yeah, there's another question, and it's kind of similar to that. What's the best approach to use our fixture bug rating to combat tier 2 and tier 3 companies? So I think a lot of the things you just talked about there, right? Finding the solution that meets the need.
Yeah, and I think probably the biggest one that's going to jump out of you, tier 2, tier 3 companies, especially compared to Cree lighting, is our optical control is to be honest is superior. We're putting the light where we want it, where it's appropriate for the application. So you're really going to start to see, say that OSQ in a similar lumen value, everything else is kind of equal. We're probably going to have a B3, U0, G3, and that tier 2, tier 3 company, which is really maybe just having very little optical control, is really creating a lot of, possibly glare. That G ratings and really the B rating too then might go up as well, but that G rating will probably start to shoot up. And I would typically, the other thing I'd say, and this is just more my experience, and not necessarily, I don't know how true it is, but in general, the B and the G usually kind of go together if you have a good optical control. And or unless you have a backlight shield or you're really trying to drop that B down for some reason with extra control, if you start to see a B of 3 and then a G of 5, I start to get a little concerned that you're getting some really high, very high angle light that is wasted. You're not using that light. You're not really using it for the application at all. It's going to cause more problems than it's worth. So that's something to look out for, is when your G starts to really shift, because it's looking at that very high angle where the backlight does not. So if you start to see that kind of be disproportionate, that's kind of an indicator of possibly bad optical control.
Yeah, last thing here, John, I just want to mention that, we do, and you did mention in your presentation, we do have backlight control sold as primarily field installed accessories. Do you test for those, and do we adjust the backlight or B rating for those?
Yes, we do. So we'll run through our photometry, to launch a product. We'll do the base luminaire, base optics with no backlight controls, and that's kind of what you saw here. I'll show this quick. So this is a typical OSQ type 3. So this doesn't look like a lot of backlight, but it's still a B3. But then we would add, you can add a field accessory that would actually create a physical barrier behind the LED portion, and that would drop it even further if you really wanted to have almost no backlight whatsoever. So yeah, we do add those control features, and sometimes for some of our products we even have the side lights or forward cul-de-sac type of shields, depending on the application. Obviously those are probably less than 5% of typical installations, but you know what, sometimes it's really important for that resident, right, that we control that light appropriately, and sometimes you need to use some mechanical features to do so.
Okay, perfect. Well, John, if you want to go to the last slide, we'll close up shop. I do want to thank you for your time and presentation. I also want to thank the audience for joining us. The next live session will be on Friday. We'll talk about our connected KBL high bays. We did some work with Uline, so we'll kind of review that project. And then on Monday, we'll talk about specialized street lighting applications for people and wildlife. So we'll kind of go through some warmer color temperatures and have some discussion around that. And then on next Wednesday, our industry session will be around the IES, the lighting resource for the industry. So with that, thanks for joining us. Again, all the sessions are being recorded. You can find that content on our YouTube channel. Thanks, everyone, and enjoy your day.